final example of using substitution to evaluate definite integrals. We have the interval from 2 to 7 of x over square root of x plus 2. So let's take a look at this and see what we can do with it. What I've done is I've gone ahead and let u equal square root of x plus 2. And the derivative of that is 1/2 times x plus 2, the quantity to the negative 1/2. And therefore, if I solve that for dx so I can do my substitution, I get dx is equal to 2 times quantity x plus 2 to the 1/2 du. All right, so then the next step, I'm going to go ahead and substitute in what I can. And it doesn't look like I've made much progress because remember my goal is to get rid of the x's and put everything in terms of u in the hopes that that will make this thing simpler so that I can find the antiderivative. Well, let me simplify this expression a little bit by removing the 2, and we see that we still do have some x's in there, so we're going to be very clever. We let u equal to square root of x plus 2. Now remember from algebra the old trick, you can square both sides. U squared is equal to x plus 2. Therefore x itself is equal to u squared minus 2. So now everywhere we had an x, we can go ahead and replace the x with u squared minus 2. This leaves us with some simplification to do. So look at the next 1, 2, 3 lines and make sure you can do the algebra to simplify, and you should be able to simplify this down to 2 times definite integral from 2 to 7 of u squared minus 2 du. Now that's pretty easy to take the antiderivative of. And you end up with 2 times 1/3 u cubed minus 2u. There's your antiderivative, and now you need to evaluate that. And your new lower boundary is going to be where x is equal to 2. So we're going to have to put that into our expression for u. So remember u is equal to square root of x plus 2. So we're substituting a 2 in there for the x to get that lower boundary. And the upper boundary, originally x is 7, so we have to substitute that into the expression for u. So we would have u is equal to square root of 7 plus 2. So now it turns out our new lower and upper limits, we're going from 2 to 3, where u equals 2 up to u is equal to 3. And now you're going to evaluate that in the usual way that you evaluate definite integrals, and you should come out with 26/3.